Hey guys, what's going on? Glove here. Welcome back to another video. I hope you guys have been enjoying this series. In this one, as you can tell from the title slide here, we're going to be talking about replicated load balancing, which is a much more meaty and I don't know if I'd say interesting, but it's a meatier topic than what we've been talking about thus far. And we're kind of starting to build on top of the other things and get to the really kind of less theoretical stuff and more tangible stuff that we can actually talk about in real world applications that might seem a little bit more interesting to you, or maybe you've even come across in your own path thus far. So let's ask a question. What is load balancing? And to answer that, we have to take a look at two different things. Number one, load balancing is when two or more services act as one. And number two, it's when we evenly distribute requests. Okay, so I know that was still kind of abstract, a little bit theoretical, maybe seems like we have our head up in the clouds a little bit. So let's take a look a little bit deeper. Let's say we have, we have to ask ourselves two questions now. Number one, how does this work, right? So let's talk about what it actually looks like. And number two, why would we actually need this? What is this theory, this abstract concept actually leading towards, right? All right, so now we're actually going to have a slide here, or a diagram here. So let's say we have an application, and this is, I use Go a lot, so, we've written our Go application. Maybe you're using Node or Python, whatever it is. Like, you've written your application, right? And you want to get it out to the world, right? You want the internet to be able to use it, right? So what's wrong with that? Well, nothing really. I mean, people can now use this. The problem, well, let me take that back. Let's go a step back. There is no problem just yet. People can use this. They will have success using this. But what happens when you reach 100 people, right? When it's just you developing it, there's no problem. When it's just your parents or your friends using it, there's still no problem. But what happens when your neighbors and the people down the street that you don't even know, or your friends tell people and then their friends start to use it? How does it scale, right? Like, does it still work under that increased load, we call it, right? Or better yet, well, actually, I'll save that. We'll get there in a little bit. So what do we do instead? Well, what we can do is we can kind of, instead of scaling up, it's called, our server. So let's say we were using the smallest instance available to us from our cloud provider, and then we upgraded to the next size and the next size and the next size. So instead of doing that, because that would inevitably get really, really expensive, what if we kind of replicated them so that we have a bunch of really cheap, inexpensive servers all running the same application, and then we just kind of served the requests. Let's say it's an API. We served the requests kind of, evenly, but it was able to work as its own service, as a single service rather. So that's what we're going to do. We're going to take our application, we're going to create what are called replicas, which are basically just exactly what they sound like. They are a replicated instance of our service, right? So we'd have three different versions of we'd have three different instances of our application running. And now we have the internet, and the internet wants to use it, so what do? Well, we stand something up in between those two things called a load balancer. And the load balancer is, again, it's going to make all three of these servers running our application, it's going to make them work as if they were one application, so that the internet or someone else's app or our app on the front end only have to make a request to one single endpoint, and the load balancer will really just take care of the rest. So let's talk about a high availability API, right? This is kind of fun. This is our first example here. Let's say that we had user 1, 2, 3, and 4. And they wanted to use our server, but they wanted to do it at the same time. The load balancer would enable them to all be able to get served their requests and have their requests fulfilled without having to worry that the server might be unable to handle the increased load. So there's only 4 users here. Maybe I didn't convey the message that well, but let's pretend that each user is 10,000 users. Let's pretend that each one of these user blocks here represents 10,000 users. That'd be 40,000 users. So now we can see how this load balancer really actually helps us out. But why else would we need a load balancer? One of the concepts that we'll come across, or that you will come across, is called high availability, or in this case, 99.999% availability, which comes down to minutes of downtime in an entire year. Sometimes you'll also hear this this term thrown out called the 5 nines. And this is generally something that if you're working for a business that has enterprise deals and business agreements with your cloud providers, this is something that generally they'll only provide to people who are paying them and have contracts in place. So, for example, if I went onto AWS and started doing stuff, I probably wouldn't expect to get 99.999% availability of their services. Maybe it's more like 99% or 99.5% or something of that nature, right? But basically, where this comes into play is, well, it comes into play in all aspects, but one example where we can see it is when we're upgrading software. Let's say that, we come out with a new version of our API, and we need to deploy that version into production, right? If we had one instance of our application, so let's say these boxes at the bottom that say API replicas 1, 2, and 3, if we only had one of those, we'd basically have to take down our service, our API, while we did the upgrade. And so basically service wouldn't be available to anyone, to each of these users that were trying to access it, right? Sometimes this is okay if you have old legacy technology, or you're working in closed networks with big enterprise customers. I worked for a company that did that, and that's okay as long as you agree to it. But generally speaking, you want to be able to provide that high availability. And so what we'll see is that what we're able to do with this load balancer is that we can take down one of these services. So let's say we take down API replica 3. And we only have API replicas 1 and 2, right? What happens is that those replicas can handle the load while we apply our new deployment, our upgrades, our updates to API replica 3. We then move API replica 3 back online, and we do the same to 2. And then we do the same to 1 once 2 is done, right? And so in this way, we're able to provide a more robust and durable service to our end user, which is, of course, the goal in this case. Let's talk about something else. Let's talk about session tracking. This is pretty important because let's say that you had an API that needed to, the user needed to log in, right? So they log in on the front end, and a specific replica, let's say it's replica 1. Replica 1 basically is the one that serves that request to basically recognize that that user is now logged in. Well, what happens if we then have another request from the user from the front end and it goes to API replica 2? API replica 2 doesn't think that user is logged in, so they might give them an error. So we have to basically track the session, which is basically, a session is, I think a session is probably self-explanatory now that I'm thinking about it. But what we have to do is we have to be able to track that session to make sure that whatever API or whatever replica the server is, or the user is served at the beginning, at the whenever the session starts, we have to make sure that that replica is always the one that serves that particular user, and we have to do this for every single user. So what do? Well, what we could do is we could put a cache layer in, right? So this cache layer would basically, the load balancer would go to the cache layer, say, okay, do you have this user's information, right? And then if it does, great, then that's the replica that gets served. And if it doesn't, it would, I guess, have to go to, the next cache and say, okay, well, do you have it? And if it doesn't, it either has to go to the next one if there is one, or if there isn't, it basically creates the session. This is great, it's fine, it'll work, but you basically have to scale this. For every replica, you need a new cache, a cache layer, right? And we have to check a bunch of cache layers in order to figure it out. So instead what we could do is we could put the cache layer in front of our replicas and basically say, okay, hey, cache, like, do you know where we should go? And if it says yes, we send them to that replica. Let's say it's replica 1. But if we don't, then it picks a random one, right? Depending on wherever it should go. And so in this way, load balancers, in addition to cache, allow us to have high availability, really, really robust and durable working services. There are some considerations though. So let's say that we have this API, and I guarantee you come across this even if you didn't really realize it, but you've definitely come across this because most APIs will have a limit, or services in general, not just APIs. Well, I guess, yeah. Most services will have a limit, how many times per second you can make a request, right? So what we want to do is we'll want to do that, right? We want to have this rate limit, it's called, so that people can't maliciously just, you know, really kind of like attack us and crash our servers with overloading what our system is capable of doing, which might also end up costing us a lot of money as well, right? So we want to have that limit. Perhaps we have, if you're unauthorized, so if you're offering a publicly available API, maybe you have a lower rate limit, and then if you're authenticated and you're, using things in that nature, you have a higher one, and then maybe you have a premium tier, which gives you yet a higher rate limit. However you want to do it, but there should nevertheless be a rate limit. The next thing we want to do is have a 429 error, which is what will return when they come up against that rate limit and can no longer make any more requests until, whatever such and such period of time goes by, or however you want to do it. And then another thing that we want to do is we probably also want to indicate the remaining rate limit. And this is just kind of good practice, something that you want to do, because people are going to want to know, whether programmatically or the developer themselves is going to need to know, how many more times can I make this request? And they need to be able to act accordingly depending on what that number is. So things that you want to do when you're building out your services. So I think that's it. Yeah, I think that's it. So thank you guys so much for watching. If you learned anything, great, that's awesome. Please subscribe. I think you'll enjoy the content that I have on this channel. And if you're interested in seeing something else, definitely let me know down in the comments or give me a thumbs up. That's also awesome too. Thanks. Take care.